Hello. Good morning. Good morning, class. Today is a Thursday. How's everybody? How's everybody today? Today. Ba, ba, ba. This concludes the audio test. Good. All right. Oh, lattes always make the morning brighter, I find. Oh, well, it's kind of a gray day, you know? Kind of seems like winter is having one last kick at the can. But, yeah, no, I'm doing pretty well. I'm feeling upbeat today. I've been taking my vitamins. Last week I was a little bit down, you know, just all of the everything, I'm sure you know. And then my wife was like just sort of casually at breakfast in the middle of last week just kind of slid the vitamins I'm supposed to take over in front of me while I was eating breakfast, and I took one, and I've been taking them since then, and I've been feeling better. But yeah, it's really interesting how like just taking vitamins can make you feel like you're not a horrible person. Like it's interesting that they have a psychiatric effect, shall we say? But yeah, no, I'm doing good. Thanks for asking. Yeah, I must be deficient in like magnesium or something. Who knows? Is there a lot of tests today? Our viewership's kind of low. Does anybody have an explanation for why there's like 10% of the number of people who are supposed to be here? It's like 30 degrees where you are. Celsius or Fahrenheit? Because those are two very different scenarios. Yeah, vitamin D is especially important during the winter months in the northern hemisphere because you're not getting the vitamin D from the sun, right? So you need to supplement it. Physics. Yep. Well, BC gets almost no sun anyway. Healthy body, healthy mind. Very true. Physics test, calculus midterm. Yeah. Yep, iron. Yep. Yeah, I find like I eat a healthy balanced diet, you know, or I try to at least. But, you know, I don't know, it's like I think to some degree it's the naturalistic fallacy. Like people think that if they eat naturally, they're getting everything that they should be getting from their food. You know, quote unquote naturally. And sure, eating lots and lots of fresh veg, and, you know, whole foods. We're big on whole foods in our household. We always we make complicated stuff, but it's always from whole foods, right? We do eat meat though. We are omnivores in this household. And I don't know, I think like show me the proof that you know, the diet that human beings originated with in the wild, so to speak. Show me the proof that that actually does contain all of the nutrients you need. Sure, you evolved in the environment, but it's not like you know, when we were living on the African veldt, we were all, you know, I imagine there was a fair amount of malnutrition that was going on there too. Anyway, Food is getting less and less nutritious. Well, that's, you know, probably a consequence of, industrial agriculture. But, we are also, on the one hand, the food is getting less nutritious. On the other hand, it doesn't look like the human race is starving to death yet. And if you take a look at some of the literature from the 1960s, they definitely thought that the Earth would run out of food by about 15 years ago. So, what do we got? Nearly 8 billion people on the planet right now? Maybe slightly over 8 billion? I can never keep track. But, just being able to feed all those people, I feel like that's that's an accomplishment, man. Even if the food is getting, less nutritious. Hopefully it'll bottom out. A lot of people, oh my goodness, I'm so rambling today. But a lot of people are sort of super against genetically modified crops, but I'm like, dudes, we need to be able to feed the people, Like GMO, like genetic editing is like there's so many benefits, and the idea that, it's somehow harmful, to me, I don't see the evidence of it. I think it's primarily based in superstition. But anyway, we should probably keep rolling with our material today. Nobody really cares what I think about genetically modified crops. But anyway, thank you, the brave, the loyal, the few, for coming to class today, despite the fact that there are midterms all over the place for both calculus and physics, which, it just seems cruel to have calculus and physics in the same day, wouldn't you say? At least I'm not giving you a midterm this time. Okay, so we had a bit of a hiccup last time. We were going to do a more complicated example of how to use classes to enforce data policy, but the last 10 minutes of class got cut off for anomalous reasons. Basically, the reason that happened was my Ethernet cable pulled out of my computer because the clip on it is broke, which is a very stupid reason to lose 10 minutes of lecture, but that's the way it is. So if you guys look at my computer right here, right now, you'll notice that my Ethernet cable has been taped in. So there's hopefully less chance of it pulling out and us experiencing the same problem this time. I'm hoping, anyway. So, come on, you. Yeah. Why does he play with this camera? He should not. Oop, jeez. Stop it! Come on. Come on. You stupid. Yeah. All right. There. All right. So, anyway. So we were talking about data policies. Let's see. Is this... Yes. How do I feel about human gene editing? Okay, I will answer very briefly. If it's like, it depends on the manner in which it's being used. If it's being used to cure diseases, I am 1,000% in favor. 1,000 million% in favor. Like, there are all kinds of genes that just cause us no end of trouble. And if we were to sort of selectively, where a disease can be isolated to a bad gene, I see absolutely no reason why you couldn't, go in, fix it, and then you don't even have to, you only have to fix it once, and then it's good for the rest of the human race. It's awesome. Things get a little more dicey when it's gene editing to improve intelligence or strength, or, it's like, if I were to put it in RPG terms, I think you can make the most clear-cut moral case for removing the debuffs on the human genome. When it comes to adding buffs, that's a little bit, more dicey, because it's like, definitely the people who have the money to do so will have a, genetic advantage. But, at any rate. So yeah, if we're fixing diseases, I'm all for it. Yeah. I read some research on how GMO is used incorrectly and used just to make food larger and better looking, not necessarily more nutritious. Yes. Yeah, no, like, you can tell from the strawberries that you get from the States now, because they're, like, this big, But they don't taste like you bite into them and it's like water. There's no flavor to them at all. So, I have to believe that eventually people will, well, I was about to say eventually people will pay less attention to appearances and more attention to substance, but that seems to be a perpetual problem with the human race, doesn't it? Definitely there's a lot of GMO that's going on behind the scenes to, adapt crops to environments that they couldn't normally survive in, make them cold hardier, for instance. And it's really, in my view, no different from selective breeding of crops. It's just a drastically accelerated process. So, yeah, no, also, if we are concerned about climate change, which, typically we are in Canada, North America, given that the environment is going to become more harsh, the ability to rapidly change crops to be able to handle more harsh environments seems like a stupid thing to throw away. So, anyway, let's get to actual computer science. So we were talking about data policy. So, just to quickly recap the idea, whenever you have a data structure in a computer system that always conforms to a particular form, right? Whenever the data is always going to be used in a specific manner, you have what is referred to as a data policy. That is, you have a set of rules that govern how the data is to be created and accessed. So the problem with data policies, generally, is while it's good to have them, right, it's extremely useful to have data policies because this you may have noticed, it's actually a bit of a pain in the butt having to plan for every single contingency about what your data is supposed to look like every time you write a function, right? It's useful to have a data policy because then you can say something in your documentation like, I expect this to be the input, and if it isn't, it's not going to work. The problem is when the data policy is implicit. When it's implicit, when it's written by you and you don't document it anywhere. Because, hypothetically speaking, when we write code, we are not simply brains in jars writing code for ourselves that never is seen or touched by anybody else in the world. In the real world, when you write code, other people are going to have to minimally use your code and maximally co-develop code with you. So, if you have rules in your brain about how data is to be used, and those are never expressed anywhere, nobody's going to know what they are, which means nobody's going to use your code correctly, which means problems. bugs galore. This is basically what you have done. What you thought you did was write a program, and what you actually did was write a bug factory. So, this is an example of a data policy. We've got a bunch of dictionaries which all have the same keys, right? Dictionary always contains, in this example, 3 items, and has keys name, children, and spouse. Therefore, if we access a dictionary that is of this form, we can rely upon the fact that the keys name, children, and spouse exist within the dictionary, which is a useful thing to know. So the problem with doing this with dictionaries, though, is while you can set things up this way, there's no level of enforcement. So documentation enforces things at the level of people reading your documentation and understanding what the heck you're doing. You can use classes to set data policy in code so that it cannot be violated in code. I love to see interesting discussions going on. But, you know. Anyway. So, this slide illustrates just a couple of the ways that these things can go wrong. If you misspell one of the keys when you're accessing the dictionary or creating one, then things are going to bork up in a manner that's probably not easy to detect. So you want to avoid that. But, you know, if in the ideal case, we would have the computer tell us somehow when we make a spelling error when accessing one of these things. Another problem is, although, like, if we are relying on the type or isInstance functions to tell us what the thing is that we're dealing with, that's frustrated by this process because there's no information available at that level other than this is a dictionary. In the same manner, you can't write a doc string that applies itself to one dictionary. Not possible. So, we're going to use classes to create a customized data type. So, here's how it works, folks. This is our first real class. So, you know how last time in class I said this is really important and you should pay attention? Well, this is really important and you should pay attention. So, class person. By convention, class names are capitalized, but that's not necessarily the case. In this case, we are inheriting from nothing. Don't worry, we'll talk about inheritance. For now, just leave it blank. In order to define, so what we're doing now is we're going to create a class that represents one of these entries. All right? So what we want to do is we want to create class attributes, or variables within the class, for name, children, and spouse. So, we've got, and we want to give them initialized values. So name is equal to blank string, children is equal to empty list, and spouse is equal to none. Cool. But this is not sufficient. In order for this to work, really, in order for this initialization to work, well, at least, we need to, pardon me, we need to put these initializing statements inside of an initializing function. So whenever an object is created from a class, remember, classes are the templates, objects are the instances of that template. Whenever an object is created, it automatically runs what's known as the initializer, or the constructor. Other languages call it a constructor. So it always has the same name, underscore underscore init underscore underscore. The underscores denote a magic function, but you don't. Basically, these are functions that are sort of class functions. You're overwriting other functionality that would have been provided, but that doesn't really matter. Again, this is a lot at once, but we'll get into it. For now, underscore underscore init underscore underscore, that is the initializer or constructor. So, all functions inside of a class, all methods, must take as their first argument self. This is a self-referential variable. Self is the object on which this method is being called. We also have to, using dot syntax, assign these variables to the context of the class rather than the context of the constructor function. The way that these things are right now, they're local to this function. But what we want them to be is we want them to be local to the class itself, not the function. So what we do is self dot children, self dot spouse. This places them in the context of the class itself rather than the context of the initializer function. So there we go. Questions? So, in order to use a class to create an object, you need to, it's done basically in the same way that you would do a list or a variable. So let's say we had X is a person and Y is another person. Right? Let's, at the end, print X dot name and print Y dot children. Just for the sake of argument. So, if we execute this, you see we get a blank line, which is a blank string, and we get an empty list, which are the initial values for, those are the values that we're initializing the class with. We can modify the attributes of a class, or the attributes of an object, directly using assignment. So, name is Marcus Farkas. Y dot children is equal to Harry, Curly, and Mo. Or is it Larry, Curly, and Mo? I'm not sure. Oh, it's supposed to be a... yeah. Boop, 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 boom, boop, 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 boom. Those are the Three Stooges. So you can see these values are assigned to the attributes of this particular class, and they're stored there, right? In the same way that a dictionary stores values, this is a class storing values. And I just want to demonstrate one more thing about this, which is that these two objects, X and Y, these are objects that they don't communicate with each other, right? They are separately declared and separately existing entities. They don't share values. See? So the third one here is x.children. X.children is still blank because it hasn't been assigned to. However, you should also be aware that when you're dealing with classes, all of the rules that we learned from aliasing with lists also apply to classes. So if we had z is equal to x, or z is equal to y, I'm pretty sure, yeah, that works. And maybe even if we do it beforehand here. Oh, y is not defined. There. Yeah. See? This assignment is made before children is assigned to, which means that this is an alias situation rather than a, it's not a duplication. It's an alias. Let me see if we have any questions. Heh. Didn't know Python was British in it. Well, it is named after Monty Python, so... Can I talk about self quickly? Yes. So, yeah. I'm jumping ahead in the slides a little bit here, but that's okay. This is sort of always how this topic goes. So, self. It makes more sense if we write another function. So I'm going to add a new function to the, or I'm going to add a new method to this class, which will hopefully demonstrate. It'll demonstrate what self does and is. So let's define make old. Self and old factor. So this is going to be simple. What it's going to do is it's self.name is equal to old times old factor concatenate with self.name. So, let me just make this a little simpler. If we call x.makeOld 3, you can see it prepends old Marcus Farkas onto the, right? It's just, it takes this guy and maps, like the 3 gets dropped in here, right? Self refers to x. Now, it turns out that in Python, you can actually, this is syntactically equivalent to the following. You can do person.makeOld x and 3. So when you call a method in this manner, you're invoking the method directly from the class definition rather than from the version of the function which is attached to the object itself. So, since you're kind of pulling the function out of the ether, it's not attached to any class, it's not attached to any object, right? So the object that you have to, the object that you want to perform this action on must be provided as an argument. And, okay, so I've made things more complicated to make things simpler, but notice now that we have an exact matching between the arguments being provided to the method and the arguments as described in the method inside of the class, right? X is self, 3 is old factor, right? So, generally speaking, if you do x dot and leave out the first argument, that's Like, that's more compact notation for the same thing, right? I'll just demonstrate to you that this actually works. There, see? It works. So, self is self-referential. And again, in order for a variable to be referenced to the class rather than locally to the function, it needs to have self dot in front of it. You need to be accessing it within the class as if you were referencing it outside of the class. You just use self. You can actually use any you can use any identifier here instead of self, but self is conventional for Python programmers. There's no reason not to use it, so generally people use it. So is self just whatever variable you pass through? No, it's the object, right? So the fundamental thing that you have to understand classes is that an object of a class is a packaging of variables and functions. So when you look at X, you should think of X not as just a container for variables. You should think of it as a thing that also has functions attached to it, right? You can access the functions in the same way that you access the variables. Like, you notice when we call the make_old method in the regular sense, we're accessing the function in the same way that we're accessing the attribute. We just, we provide it arguments because it's a function, right? So, so the variable does get passed through, but always remember that the first guy here, that's always going to be whatever object the method is being called over. So, and that's one of the key differences with classes. The functions are sort of grounded in reality. They're like, they don't exist outside of the context of an object, right? That's why classes enforce data policy, because you can't just willy-nilly call a function from a class without having an object of that class that you can refer to. So, I know this is pretty complicated. Is there anybody? What happens if you use the type function on X? Good question. Excellent question. Print type X. Ooh. Class main.person. Cool. Right. So, I'll just take like a minute or two right now. If anybody has any questions about this, please ask it now. This is super important that you guys brain around this. This is important stuff. A thumbs up, maybe? Okay. Okay, so let's see how many slides we covered. Oh, how do classes differ from dictionaries? They appear to perform the same function. So, in this particular instance, there's not much difference between our class definition and the dictionary that we're doing here, right? There's not much difference, but that's only because we haven't started doing the complicated stuff yet, right? So, excellent. So, keep the following things in mind. These methods can be as complicated as any of the functions that you guys have been doing for assignments. So keep that in mind. This is a simple one, but, you know, these guys can get much more complicated. Number 2, these guys can be arbitrary structures, right? These can even be objects of other classes. These can even be objects of the same class. If you have attributes of a class which are objects of the same class, you have, a recursive class structure. Recursive class structures are probably something that you're going to see quite a lot if you're doing a minor in computer science or a major in computer science, because there are certain types of algorithmic problems, particularly ones that involve nodes and graphs, like a tree, like a binary tree. You have nodes and you have branches, right? The node is one thing, like a number, and the branch is like a pointer to another instance of the tree class. Like, you can have really complicated structures here. Although things are pretty simple so far, that's just because we're using the simple stuff to explain things simply. So don't worry, things get more complicated. Why is your question not going? Okay. Cool. So essentially, I'll go through the slides that we've covered. So yes, classes can be used as a custom data type. They enforce the policies that we established here, right? If you misspell children, you get an error, right? Like if I misspell something, well, actually, what it'll do, it will create a new element in there. So, if we print just that, it's like, you know, ordinary, like in a good programming language, it wouldn't do that. But in Python, because everything's so dynamic, you can create instances, you can create attributes on the fly that aren't defined in the class instance, which does kind of contradict all of the business I was talking about enforcing a data policy. But you know, it is possible that this stuff was adapted from how classes work in C++ or something. Anyway, custom data type. So yeah, we create custom data type. We already did that. So we won't talk about inheritance yet. We have much better slides on inheritance coming up. So the initializer initializes or constructs the instance of the object, as we saw. You don't, like, this is how you declare one, right? Init is a special function called an initializer. It gets called whenever we try to make a new instance of the class. Inside the initializer, we can define instance variables that are associated with each instance of the class. Instance variables are sometimes called members, properties, or attributes. Cool. Different instances of the same class will have independent instance variables, as I demonstrated. Wow, I covered a lot of slides. We can also add functions to the class. These are called methods or member functions. So in this case, they're doing isMarried, which is just simply returns the a Boolean condition to see if the spouse has been assigned to or not. If the spouse has been assigned to, then you can be reasonably sure that the person has a spouse, which means they are married. Fine. We did a different one. So, cool. There. So everything in Python is an object. Literally everything. If I were to pull up the Python interpreter, the number 7, right? What's the type of the number 7? Class int. So, the integers are members of a class. What is the type of type? I need to... Yeah, there you go. It's class type, right? What is the type of absolute value? Class built-in function or method. Even functions. Functions are classes. Ints are classes. Floats, strings, lists, everything. That's what makes it an object-oriented language, is that everything in it is an object. That is how it works. So, yes. So, functions are of class function. Objects are of whatever instance they are of the class. Good. So, the class definition defines attributes, properties, variables, members, or methods that are common across all instances of that class. So, going back to our person example, if you have different persons that are declared, each one of them will have all of the attributes which are given to it by the class definition. So, every single one of them has an initializer which is defined in the same manner. They all have the same make old function, and they all have all of the same attributes or member variables. Attributes of a class or object are referenced using dot notation, as we have seen several times. Here's another example. We have a point class. So this is a class for points in Euclidean geometry. Hopefully everybody loves Euclid. I know I love Euclid. Euclid is my homeboy. So, class, point. We will initialize def init takes self, an x0, and a y0. So yeah, with initializers, you can have variables in there other than self. You can have as many of them as you like. Self.x is equal to x0. Self.y is equal to y0. Incidentally, I just want to take a brief moment to say that the class system in Python sucks the big one. It is terrible. Classes in Python are so bad. I hate it. It's like, as I'm typing this, the bones in my fingers are trying to rip themselves out of my hands because they're so embarrassed by how bad the class system in Python is. If you compare it to something like C++. Because it's the same problem. It's the dynamic programming bollocks. So anyway, so we have a translate function. Takes self, takes a delta x and a delta y. It does something very simple. Self.x plus equals delta x. Self.y plus equals delta y. Def scale, self, and some scale factor s, self dot x times equals s, self dot y times equals s. And distance, def distance, takes self and it takes other. So other is the conventional way when you're referring to two objects of the same class. So think about integer addition, right? If you have 7 plus 3, 7 would be self and 3 would be other. So return other.x minus self.x squared, not cubed, squared, other.y minus self.y also squared, all of that to the power of 0.5, which is, of course, our shorthand for square root. So, there we go. So let's define a couple of points. Let's say x is a point at 4 and 7. Y is a point at 9 and 10. Right? So let's x dot move minus 2, 5, and then print x dot distance y, and we shall see. Invalid syntax. Gosh darn it. There. Cool. So we get this, which, you know, I'm sure if you actually do the geometry, that's how it would come out. I am reasonably confident in that answer. So, methods are called using dot notation. The first parameter, named self by convention, is bound to the object. So, again, x.move minus 2, 5 is the same as point.move x to 5, right? That's the same thing. And notice, again, this matches up to the manner in which the arguments are actually displayed inside of the class definition itself. The init method is called implicitly when an object is created. Its parameters have to be supplied at object creation. So, you can't, for example, create a blank point in this example, right? In order to be able to do that, you have to provide default arguments. That's right, folks. Default arguments work inside of the context of methods as well. And, of course, our value would change because it's no longer starting from the same position. So, there we go. Any questions about this? So, yeah, I don't think we're going to get into that today, just because we're only 2 minutes out. So if you have any questions, please ask your questions now, and I will answer them. Keep in mind that I'm also having office hours after this stream is terminated, and I have had time to make myself a cup of tea. So, Can I explain the distance again? Yeah, sure. So distance is taking... So the difference between distance and something like scale, for example, is that we are assuming that the second parameter here, other, is also... Ooh, let me turn myself off. There we go. Other is also an object of the point class, right? So when we call distance here, y is another point object. That way, and you like... So again, in a useful programming language, you would have like a declaration of what these things are supposed to be inside of the function. But because we don't have that, because this is bloody Python, it is a point because you use it like a point. So because we're accessing other.x and other.y, and those are the elements, those are the attributes of a point class, this is essentially what sets it as being a point. But, you declare 2 points, you can do x.distance y, and I believe we can reverse it too. Y.distance x has the same effect. Yes, there we go. Something would have been horribly wrong if that didn't come out. So yeah, you can see other and self are being used in the same manner within the context of the distance class. Oh, one other thing though. You'll notice, I think this is the first time we've had a method with a return clause or a return statement. Methods of, like, with respect to methods, there's sort of a much higher incidence of them not having return values versus regular functions, like the kind you would do for your assignments. For your assignments, we're pretty much always having return functions. But with methods, a lot of the time, the output is kind of implicitly the modifications that you're making to the class's attributes. So a return value is really only used if you want some data to escape the object. If you want data to get out of the context of the class, then you use a return function because that passes it up through the chain. So you can, in some sense, it's generally the case in object-oriented that when you have methods attached to a class, you think of some of them as being getters and some of them as being setters. So setters are methods that set values, and getters are methods that extract values, or they get information, right? So hopefully that clears things up a little bit. Was that a good explanation? Hopefully. Okay, all right. Thank you very much for everybody. If you have any questions, see you in office hours. And yeah, have a good weekend. Don't go crazy with calculus and physics exams. Just remember, math is ultimately a construction of the human mind, not the other way around. So, you can master math. It is possible. Take her easy, folks.